Welcome back friends, welcome back to another video session from this channel. So in this video session we will be studying regarding the activity of Gre factors during the elongation phase of the transcription mechanism. So as I have already mentioned you earlier, during the initiation phase of the transcription mechanism, the specific RNA polymerase enzyme, by taking the advantage of sigma factor, it successfully recruits to the promoter region. So once when the RNA polymerase enzyme, by taking the advantage of sigma factor, when it successfully recruits to the promoter region, under such condition, it leads to the formation of a specific complex, and that specific complex, it is nothing but what? Closed complex. So once when the closed complex, when it successfully forms, under such condition, the promoter region, it undergoes melting. So once when the promoter region, when it undergoes melting, now the RNA polymerase enzyme, it is capable to associate with the promoter region so accurately. So once when the RNA polymerase enzyme, when it is capable to associate with the promoter region so accurately, under such condition, now the RNA polymerase enzyme, it is capable to unwind, or it is capable to separate the double-stranded genomic sequence. So once when the double-stranded genomic sequence, when it undergoes unwinding, under such condition, closed complex, it successfully converts into open complex. Is it clear? So for your better understanding, let me present it on the board. So let us assume it has the 5' end. And here it is nothing but the 3' end. And here it is nothing but the 3' end. And here it is nothing but the 5' end. Is it clear? And here all these are the nucleotides. So it is nothing but the RNA polymerase enzyme. RNA polymerase enzyme, which is in association with the sigma factor. Sigma factor. And here it is nothing but the open complex. Open complex formation. So this is simply termed as transcription bubble. Transcription bubble. Is it clear? So once when the transcription bubble, when it successfully forms, formation of transcription bubble, it indirectly suggests, or it indirectly says that the transcription mechanism or the transcription process, it is ready to fire. So here the RNA polymerase enzyme, without taking the advantage of primer, it is capable to incorporate the RNTPs. So most commonly, as I have already mentioned you earlier, the specific RNA polymerase enzyme during the transcription mechanism, it incorporates AT as the initiating RNTPs. Is it clear? So let me write it here. What are those? AT as the initiating nucleotides. That means in case of the template DNA, the specific nucleotide, it should remain as T, and whereas in case of the nascent mRNA, the initiating RNTP, it should remain as adenosine. Is it clear? So as we all know, in nature the weakest hydrogen bonding in between the two successive nitrogenous bases, it relies in between A and T in case of the DNA, right? So here once when the RNA polymerase enzyme, when it incorporates AT as the initiating nucleotides, under such condition, the initiating nucleotides, it successfully dissociates from the site of the synthesis. Is it clear? So let me present it here. So all these are the initiating RNTPs which were dissociated from the site of the synthesis. So here, though the initiating RNTPs, though they were dissociated from the site of the synthesis, but the RNA polymerase enzyme, it remains in association with the promoter region. Is it clear? So here the RNA polymerase enzyme, it is capable to incorporate the RNTP so accurately until when there is an accurate base pairing in between the nascent mRNA and the template DNA. So here this specific phenomenon, this specific process, it is nothing but what? Abortive initiation, as I mentioned you earlier. Is it clear? So let me write it here. What it is? Abortive initiation. Abortive initiation. So this is nothing but the RNTPs, right? Initiating RNTPs. So here most commonly RNA polymerase enzyme, it incorporates RATP, RUTP, RGTP and RCTP as the nucleotides in order to synthesize the mRNA. But very rarely the RNA polymerase enzyme, it incorporates some misincorporated nucleotides like cordycepin. Is it clear? So as I've already mentioned you earlier regarding cordycepin. Cordycepin. Which is an adenosine analog. So here the specific cordycepin, it is quite homologous to the adenosine, but here unlike adenosine nucleotide, the specific cordycepin, it won't possess or it do not contain hydroxyl group at the third position. So due to the lack of hydroxyl group at the third position, when cordycepin, when it is successfully incorporated by the RNA polymerase enzyme, under such condition, the RNA polymerase enzyme, it is unable to proceed forward. Is it clear? So let me write it here. So let us assume it as the cordycepin, right? So here once when the RNA polymerase enzyme, when it successfully incorporates cordycepin, under such condition the RNA polymerase enzyme, it is unable to proceed forward. So here to overcome the problem, the RNA polymerase enzyme, it remains in association with a specific factor and it is nothing but what? GRE factors. Is it clear? So let me write it here. What are those? RNA polymerase enzyme, by taking the advantage of GRE factors. So what is the advantage of GRE factors? The specific RNA polymerase enzyme itself, it do not possess or it do not contain any type of endonuclease activity. Is it clear? In order to cleave the misincorporated nucleotide which is induced by the RNA polymerase enzyme, the RNA polymerase enzyme, it takes the advantage of GRE factors. So here the specific GRE factors, it possess endogenous activity or endonuclease activity. So once when the RNA polymerase enzyme, when it remains in association with GRE factor, under such condition the RNA polymerase enzyme, it acquires the endonuclease activity in order to cleave the misincorporated nucleotide. Is it clear? So let me write it here. What it is? GRE factor. So it possesses endonuclease activity. Endonuclease activity. So once when the RNA polymerase enzyme, when it cleaves the misincorporated nucleotide from the site of the synthesis, under such condition the RNA polymerase enzyme, it is capable to incorporate the RNTP so accurately until the RNA polymerase enzyme, it reaches the termination site of the double-stranded genomic sequence. So this is regarding the activity of GRE factors. So I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.